Hi. Now, in the previous video in this series on solving first order differential equations, I showed you that if you had a first order differential equation of the form dy by dx plus py equals q, where p and q were functions of x, then we got this general solution here. E to the integral p dx times y equals the integral of e to the integral p dx times q integrated with respect to x. Seems like a bit of a mouthful, but the purpose of this particular video is to give you two questions that you might like to try, and just pause the video, come back when ready, and you can check your work solutions with mine. Okay, welcome back if you had a go. Now, for number one, we've got dy by dx minus 5y equals e to the power x. So clearly this has got this particular format. The p is going to be minus 5 and the q is e to the power x. So what we need to do is first of all find out what the integrating factor is going to be. And that integrating factor is e to the integral p dx. So let's start off then by saying that the integrating factor, what it's going to be. So integrating factor is, right, well, it's going to be e to the integral p dx. In other words, this is going to be e to the integral of p, which is the minus 5, so we've got to integrate minus 5 with respect to x. And the integral of minus 5 is just going to be minus 5x, so we get this equals e to the power minus 5x. We always ignore the constant of integration at this point, okay? So just leave it as e to the minus 5x. Now that means that the general solution, this is this one up here, if we just put in our values, we've got e to the integral p dx, so that's going to be that, therefore, let's just write down the general solution though first. General solution is going to be, well, it's going to be e to the minus 5x, okay, that part there, multiplied by y, and this is equal to the integral of e to the integral p dx, our integrating factor, which again is e to the power minus 5x, and this is multiplied by q. Q is a function of x, and in this example it's e to the power x, so we've got that this is multiplied by e to the power x, and we integrate this all with respect to x. Now we can tidy this up. Let's just rewrite this as e to the minus 5x times y equals, now if we multiply these two together we've got to add the powers, so it's going to be the integral of e to the power minus 4x, and that's integrated with respect to x. And again, if we just copy the first part here, e to the power minus 5x times y equals, and if we integrate e to the minus 4x, it's going to be minus 1/4 e to the power minus 4x. And then we've got the constant of integration, which I'll call plus c. Now if I multiply throughout by e to the power 5x, then this will just go to y, and then we've got minus 1/4, and we've got e to the power minus 4x times e to the power 5x, so if we add the powers we end up with e to the power x, and then for this last term it'll just be plus the constant c multiplied by e to the power 5x. Okay, so I'll just leave it in that format. So you might like to do other things with it. You know, you could multiply through by the 4 if you wanted to. You could pull out e to the power x as a common factor, but essentially that's my general solution. Okay, well, let's just move on now to the next example. Now in this next example, we've got to solve sine x times dy dx plus 3y cos x equals cosec x. And one of the reasons why I picked this example is because, first of all, it's not in the right format. It's not in this format. We've got to start with dy by dx. So that means that we've got to remove the sine x. And we can do that by dividing each term by sine x. So if we start by doing that, then we've got, therefore, well, dividing the first term by sine x will give us dy by dx. And then if we divide the second term by sine x, we've just got plus 3y cos x over sine x. I'll leave it like that rather than just changing it to the equivalent of cot x, okay? Just leave it like that for the time being. And then equals, and remember cosec x is 1 over sine x, and if we divide that by another sine x, we end up with 1 over sine squared x. So just mark that in, 1 over sine squared x. Okay, so it's now got this particular format, and you can see that p, which is a function of x, is in this example is going to be 3 cos x over sine x, and q is going to be 1 over sine squared x. Okay, so we next need to work out what our integrating factor is, that is e to the integral p dx. So let's just say that therefore the integrating factor, okay, integrating factor, well, what's that going to be? Let's just say is, well, we know it's going to be e to the integral p dx. Let's just put that in, e to the integral p dx. But that's going to translate into e to the integral of p, which is 3 cos x over sine x. So we've got 3 cos x over sine x. I hope you can see this. I know it's a bit squashed, but I just want to keep it all on the one screen so you can see these examples. Okay, now we've got here this integral, which is the type where the top is a differential of the denominator. If you differentiate sine x, you get cos x. So this means that this is a natural log type. It's the natural log of the denominator. So what we've got then is that this is the same as equaling e to the 3 times the natural log of the denominator, in this case sine x. Now what we do with ones like this is we remove the 3, we use the power rule for logs, so this becomes the natural log of sine cubed x. Okay, so we can change this to e times the natural log of sine cubed x. And when you've got something like this, e to a natural log of something, then all we've got to do is just remove the natural log, and it just gives us sine cubed x. So that's what we have next, that this is the same as sine cubed x. So that means that therefore our general solution, okay, is going to be using the formula that we've got up here, okay, this one here. It's going to be e to the integral p dx times y, so that's going to be sine cubed x, so we therefore have sine cubed x multiplied by y. Let's just put that in brackets there, and then it's going to equal the integral of e to the integral p dx, that's our integrating factor again, sine cubed x, and then that's multiplied by q. Q is 1 over sine squared x, so we just put that in, 1 over sine squared x, and then all of this is integrated with respect to x. And we can cancel out here, we can cancel out the sine squared x into the sine cubed x, and that just leaves us with sine x. Okay? Now, I'm just going to turn these two parts round. You said terms there, but just these two around. So we therefore have y sine cubed x equals, and the integral of sine x with respect to x is minus cos x. So we get minus cos x, and then don't forget the constant of integration, which we'll say is plus c. So there's our general solution, and again you could change this around, give anything that's equivalent to this, but I'm going to leave it like that. Okay, so I hope it's given you an idea of what you can do then when you get questions like these. Okay, and I hope that sets you up for other similar examples. Okay.